In this video, we are going to study about VHDL code for LCD interfacing. To do this task, we require one FPGA board. Right now, for the testing purpose, we have taken Spartan-3E board with 16 x 2 LCD. Objective of this interfacing is to study LCD devices to your FPGA board. VHDL code, we require Xilinx software. So Xilinx ISC 9.2 is created. So in this, we have to create new project for our LCD. So for that purpose, we have to go to the new project. Here you have to give the project name. So here is my LCD project. Top source hardware language is HDL. We have to select. So let it be. Now here you have to few changes you have to do it for the device properties. As we have to use Spartan-3E kit, so you have to select the Spartan-3E family. In that device you have to select it XC3S250E. As PQ208 is the package, so you need to select PQ208 package with speed 5. So these hardware settings for your device, it is mandatory to select all these settings. Then click on next. Once you finish with this, your project will be created with the source file. Now in order to that, we need to add the source file to our project. So in that manner, you have to go to the project, and here you have to create the new source. So click on this project new source. In that manner, go to the this particular VHDL module. So here you have to give the source file name. So again, I am giving the source file name LCD, and that will get added to my project here. So right now here the entity and architecture, I am just skipping this. I will add these details in my source file once it is created. So I'll just click on next and finish. Once you're done with that, you could able to see one lcd.vhd file into it. So here is your lcd.vhd file. So as per this VHDL code, as you know that there is a three components are present into your VHDL code. That is, one is library, second is your entity, and third is your architecture. So let's start writing your entity. Now in this particular LCD, you need to write USDP signal, which is active low signal, which is in the form of a reset state. So I will write generic reset underscore state as a signal with the condition as a standard logic signal. Assign value to the signal is 1. Then in that respect, you need to add ports. After this LCD entity, we need to write architecture. Now in architecture, we are taking constant. So here I am declaring some of the constants. N constant, and this n constant is of let's say integer with the size 40. So in this particular array, 14 elements I could able to notify it, and in that I can simply say that it is a combination of your codes, LCD codes, LCD executable commands and data which I wanted to print it on LCD. So here is 14 integer value for the n. After that, I'll use type array, and this array may be consisting of 1 to n elements, and n is nothing but 14 number. So here I'm declaring to the maximum limit up to size n of your standard logic vector. Seven down to 0. Now in this particular array, as I have declared 14 elements into it, so I need to give that constant data into that array. So I will use constant data, and that datas are in the form of data name can be variable in the form of ARR, which is nothing but your array with the inclusion of, let's say, first command for your LCD in 8-bit mode to initialize is 38. So give that command. After that, second command is your 0C. Next command will be in the form of 06. Then 01. 01 is nothing but a reset. And in order to that, I wanted to display message on first line. I need to give first line command, which is nothing but 80. So these are the LCD initialization commands. Okay, if at all whatever data you wanted to give, that data furthermore you can add this in array. So let's say take out some data. So here is first data. So in order to that, this array will be consisting of all the hex uh, values, ASCII hex values that will get printed on LCD. So in that respect, you need to add these ASCII hex values so that your data will be printed without any conversion. So I'm giving the data into it right now. So in order to that, this particular data will get printed on screen. So if at all you wanted to display message as per the size of that respected string length, you need to add this array and you need to increase the size. So as per that, you need to add all the ASCII hex values in this particular array. So like this way, we have given, let's say 14 elements, including the commands and including your data. So let's begin with, as you are working with your LCD, so let's take a sensitivity signal with the case of process. So in that manner, you're going to say that here you are using clock of 12 megahertz. So the signal which you wanted to monitor based upon clock, that is clock underscore 12 megahertz. After that, as this is array, I need to take up some kind of pointers. So here I'm declaring two of the pointers. One is to monitor the elements inside it, that can be your data, and other one is for the command. So here is variable. This variable is I variable, and integer size with the initial value as a 0. Second variable is j variable. Now this j variable will be initially looking up for your commands. So here is integer. Along with that, you can assign the value as a 1. Now here, the signal will be initiated based on clock. So I need to begin with my signal. So that signal is, if your clock 12 megahertz will be considered as you are generating as a clock. So that's why you need to generate in terms of clock tick event. So here is clock underscore 12 megahertz, and the value for this is active high, so positive going edge of the clock. Then what will happen if clock is applied? Then you need to initiate the pointer. So you can assign here, as your initial pointer is I pointer, assign with the value of, let's say here, if at all your I is less than and equal to 100,000. So in that manner, you can say that it is kind of delay, and you are simply changing the value for your I plus 1. After that, you need to initialize the control signal for the first data. So you will activate this as by your enable signal. So you need to assign enable signal as a 1. So whenever you wanted to give the data, the condition for the data is RS must be, if at all it is command, then RS must be 0, RW must be 0, and enable must be 1. So here in our case, RW is grounded, so we are not considering RW, but instead of that, we are taking enable signal. Clear? So in that manner, you simply take out this enable signal as a 1 and mention here as a LCD data. That data will get printed on this particular LCD. So the data lines, for that purpose, you are taking that all data lines in the form of your datas, which is specified here in the ways of array, and the pointer for that data will be in the case of j pointer. And next step after writing your code is to check the errors. So you have to go to this synthesize option, double click on that, and it will check your syntax errors. Once no error will be there, after that you need to assign pin package. So you have to go to the user constraint and you have to click on the assign pin package. This assigning pin package is nothing but allocating pin numbers from hardware. So as we wanted to interface this LCD with our Spartan-3E kit, so in order to that, we need to assign pin package as per the pins. So this particular pin package as PQ208 package is given for our hardware. So as per the control signal and data signal, we need to follow this column. once pin package will be completed, you need to click on generate program file. Now this program file, generation of your program file will create your executable file required as per the hardware for LCD interfacing. It will create a .bit file along with the help of your UCF file, which is created after assigning pin package. So once package is assigned and after that we have generated the general programming file, after that this particular executable file in your folder it is created where you have started with your project. So that was your LCD file. So in this folder just look around for the bit file. So this bit file we need to execute with the help of JTAG. We need to download this in hardware. So here is VLSI underscore LCD underscore V1 bit file dot bit. So copy this file. Once you copy this file, you need to paste this file in this FPGA download folder. So here our JTAG application is there. So before moving on to that, we need to give this file name path in the FPGA downloader. So right click on that, edit this file. So here you will able to find the file name for the execution. Rest of the things you need not to change anything. So only the bit file name you need to add. So as I have created bit file name with the LCD underscore V1.
Interfacing of LCD, you require Spartan-3E kit. Now this kit is connected with your PC using JTAG cable. So here is your JTAG connection. So using USB to JTAG connection interface is given from your PC to this Spartan-3E. Here is your LCD. Now this LCD is 16x2. So in order to the VHDL code which is written to display one message on screen, that I2, IT, E and TC, that will get displayed by this particular 16x2 LCD. So here is the output. So with the help of your bit file, that will get executed with the help of your JTAG application, and through that you can able to run and execute the code for LCD